Hi everyone, and my name is Guanzhong Wang from Baidu PaddlePaddle team. It's my great honor to make this speech. And today my topic is PaddleDetection Toolkit and PP-YOLO Series models. And I will first have a brief introduction to PaddlePaddle, and then we will talk about the paddle detection and the details of the PP-YOLO series models. Okay, so the first part, let's move on to the PaddlePaddle. The PaddlePaddle is a deep learning framework from Baidu, and Paddle is the abbreviation of parallel distributed deep learning. And actually, at Baidu, we started apply deep learning technologies quite early at 2012. And the deep learning framework, namely PaddlePaddle, was open sourced at 2016. And after several years development iteration, our recent PaddlePaddle release is version 2.3. And during this process, deep learning technologies and PaddlePaddle framework are widely used in not only Baidu's internal business, but also in many other scenarios. And we designed the PaddlePaddle with our own considerations. Basically, PaddlePaddle is positioned as an industrial-grade deep learning platform, which means we want both development flexibility and model deployment efficiency. And given this, we have a unified design of the dynamic and the static graphs. And PaddlePaddle also support the ultra-large scale training of deep neural networks. And inside Baidu, PaddlePaddle supports the training of deep neural networks with 100 billions of features and trillions of parameters by using data distributed over hundreds of nodes. And PaddlePaddle includes and maintains the many mainstream models and deployment keys that have been polished for a long time in the industry. And this is very important for industrial use of PaddlePaddle to develop the real applications. And as you could see on our top layer, the PaddlePaddle provide many tools and components which could help more people to use AI. For example, PaddleHub gives many pre-trained models to use directly on different applications. And VisualDL helps developers visualize the whole process of the training step and evaluate their model effect. And to enable immediate use of AI models in industrial applications, the PaddlePaddle released a multi-industry model zoo covering natural language processing, the computer vision, speech, and recommendation. And there are more than 500 models in this model zoo. And today I will focus more on the object detection field and the paddle detection. Okay, so the second part is about the paddle detection toolkit. And the paddle detection is an end-to-end object detection development kit based on the PaddlePaddle, providing over 30 algorithms and over 300 pre-trained models. It covers object detection, instance segmentation, multi-object tracking, and the key point detection. And on one hand, we provide classical and latest algorithms in different directions. And on the other hand, we have industrial PP series models like PP-YOLO for high accuracy object detection, and PP-TinyPose for object detection on mobile side, and PP-TinyPose for ultralight human key point detection. And they could achieve the best balance between the precision and the efficiency on different devices and tasks. And based on that, we ensemble these models to an end-to-end baseline called the PP-Human and PP-Vehicle. And they mainly provide many applications in human and vehicle scenarios, such as the pedestrian tracking and behavior detection or the car type recognition. And as you could see, there are also many other courses and tutorials here for users with different levels in object detection. And for example, we have whole process tutorial of smoke detection and containing the scenario analysis, scheme selection, and model optimization, and the deployment demo in PP-Human. And when you look into the paddle detection carefully, you could find it get through end-to-end from the data augmentation, constructing models, the training step, the model compression, and the deployment. And it used the modular design, which decoupling the each network component, such as the backbone, neck, loss, or the other tricks. It is easy for developers to build and try various detection models and optimization strategies, enabling quick access to high performance and customized algorithm. Okay. And recently we have released the version 2.5 on paddle detection, and there are many application demos using paddle detection, such as the face detection, aircraft tracking, and the license plate recognition. I hope you could start on our repo and follow our latest work. Okay, so now let's talk about the key part of paddle detection, the PP-YOLO series models. And firstly, I would like to make a quick review of our motivation to do such things. 4 years ago, we started to develop all our object detection algorithms using PaddlePaddle, and we implement a lot of classical models like FastRCN, SSD, YOLOv3, and RetinaNet, and so on. And during this process, we found YOLOv3 was quite widely used in different scenarios, including the manufacturer, security, agriculture, the retail. However, we found that the YOLOv3 is not enough because there are still many challenges using AI in real applications, and it may suffer the hardware limitation, and the number of data samples is much smaller than the open source data set like Coco. And especially the positive samples is much fewer in like the defect detection or the lesion detection. So the higher accuracy and the faster inference speed are always the important demand for the object detection. So for us, since 2019, we keep an eye on the latest work in YOLO. And now we have released the PaddleYOLO containing the YOLOv5, the YOLOv7, and the latest the YOLOv6. And then we try to optimize the detection models in terms of the model architecture, label assignment, and other ideas. Yeah. And to get a better performance to attract more people to use our paddle detection. And now we have released the PP-YOLO series for 3 versions, including the PP-YOLO and PP-YOLO V2 and PP-YOLOe. And as you could see, the PP-YOLO series means the PP-YOLO series model from PaddlePaddle, and they are positioned as the best choice on server and edge side, such as the NVIDIA B100, T4, or Jetson NX. And in the future, we may release the next version of PP-YOLO maybe next year using Transformer series module, perhaps. And now let's see the details of the PP-YOLO series. Okay, so let's first look into the PP-YOLO and PP-YOLO V2. The inside of these 2 models is to improve the precision based on YOLOv3 without inference speed loss. So we introduced a lot of tricks like the job lock, EMA, and IOU loss, and other backup freebies. And these 2 algorithms got good result at that time. And the performance of the PP-YOLO is 45.9 MAP on Coco dataset, and 72.9 FPS on Tesla V100 without TensorRT, and it surpassed the YOLO V4 at that time. And our PP-YOLO V2 got 49.5 MAP and 68.9 FPS on the same device. We got better result compared to the first version of the YOLO V5. Okay, and for the latest version, the PP-YOLOe, the inside is slightly different. We focused more on the anchor mechanism and the model scalability and the deployment friendliness. We thought that was the core problem in the object detection field. And even we totally modified the architecture as we did before. Actually, we learned a lot from like YOLO X and YOLO V5 during the experiment. PP-YOLOe referred to the anchor-free design from YOLO X and scale design from YOLO V5. As you could see, the figure on the right hand shows our architecture and pipeline, and how we optimize the PP-YOLOe step by step. And as a result, the PP-YOLOe achieves the 51.4 MAP on COCO dataset and 78.1 FPS on Tesla V100, which makes a large improvement compared to the previous state-of-the-art models. And the PP-YOLOe also have different scaled model with S, M, L, and X version, and they can be changed just in the configure file, and it is easy to use. And in addition, recently we found that YOLO V6 just uploaded their paper on arXiv, and they used the similar label assignment method and the loss function as we did in the PP-YOLOe. So I believe that the communication between the YOLO series authors, like the YOLO vision, is quite important and necessary, and will definitely accelerate the development of the object detection. Okay, so now let's talk more about our optimization process. So our first step is to change the model architecture to anchor-free as our new baseline. The PP-YOLO V2 rely on the anchor to detect objects like the YOLO V3, which depends on much prior information and got poor generalization. Meanwhile, the redundancy box may lead to a large number of parameters. So we adjust our new baseline based on the FCOS, which is a classical anchor-free model. And it predicts the distance to edges for regression and assign ground truths to the layer by size. And in addition, we remove the operators like the deformable convolution and the matrix NMS in PP-YOLO V2 for better support on different hardwares. So as a result, the precision of our new baseline drops 0.3 MAP compared to the PP-YOLO V2 with slight improvement of inference speed. Okay, then we optimize the backbone and neck, and we firstly produced the rest block, combining the advantage of residual connections and the dense connections, and avoid the memory access cost at the same time. And you can see the block is originated from the tree block, and we minimized the implement, remaining the fusion of multi-features from the different receptive fields. Then we modified the block for reparameterization. And we think it is the first time to introduce such strategy in YOLO series in PP-YOLOe, and which is a very common trick in YOLO V6 and YOLO V7 now. And this strategy actually helps improving the feature extraction without extra calculation at the stage of inference. And the number of the rest block and the channel inside this block could be scaled. And we stack these blocks to generate the CSP rest block in our backbone and neck. And the experiment shows the MAP improves 0.7 and it could speed up 22.5 at the stage of inference compared to our baseline. To further improve the accuracy, the label assignment is another aspect to be considered. Usually, the label assignment could be divided into two parts, the dynamic and the static way. The ULOX use SimOTA, which is a dynamic strategy. It allocates the dynamic number of positive anchors for each ground truth. Inspired by that, we introduced TAL as a dynamic label assignment, and it could overcome the misalignment of the classification and the localization. The TAL computes the cost matrix according to the score and the IOU from the prediction, and select the positive and negative samples from this matrix. Actually, we also investigate the performance using different label assignment strategies. And we found that the static label assignment still works at the early stage of the training. So finally, we combined the ETSS and the TAL strategy together. After that, our MAP improves 0.9 and without the speed loss. And in object detection, the task of conflict between the classification and the localization is a well-known problem. And ULOX decoupled head draws lesson from the most of detectors and successfully applied to YOLO model. And however, the decoupled head may make the classification and the localization tasks separated and independent in lack of the task-specific learning. So we proposed the ET head based on TOOD head. We use ESE block to replace the layer attention in TOOD. And we also simplify the alignment of classification branches to shortcut and replace the alignment of the regression branch with the integral layer. And in terms of the loss function, we adopted the varifocal loss for classification and GFL loss for distribution focal loss for regression. And finally, the MAP reaches the 51.4 and the inference speed could reach the 78.1 FPS on Tesla V100 without 1030. And recently, we upgrade our PP-YOLOe to PP-YOLOe Plus. The idea is quite simple. We just focus more on the end-to-end performance and better pre-trained models instead of the model performance only. And actually, we did not change the architecture of PP-YOLOe too much. We optimized the model by adding a learnable weight on one-by-one count branch in rest block to adjust the different receptive field. And to optimize the end-to-end performance, we refined the pre-process and the post-process, including removing the normalization and the CUDA implementation for MS. And we got a better pre-trained model by training on Object 365 dataset, which could help users to refine their own task more efficiently. And as a result, the precision of the PP-YOLOe Plus improves up to 2.4 MAP compared to our PP-YOLOe. And the training duration and the end-to-end inference speed are optimized significantly. And we also verified the pre-trained model on many downstream tasks. And the best result shows the 8.1 MAP improvement. And there we compared the PP-YOLOe Plus to the SOTA detectors in L version. So as we could see, the MAP in PP-YOLOe Plus still has this advantage. And in the future, we're gonna continue to optimize the PP-YOLO series for better performance. And thanks to the achievement of all such great works in the YOLO world, the object detection field could develop so fast. And the developers and the researchers may enjoy the huge improvement on their own applications by the algorithm iteration. So, and again, we are so glad to have this opportunity to share our work in details on this event. And thank you.